Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Grace, who will be presenting on the topic of cloud native DevTools bringing the cloud back to earth. If you have any questions for Grace as we move through today's presentation, please feel free to put them in the chat or use the Ask a Questions tab. Without any further delay, Grace, over to you.
Thanks so much, Serena. It's great to be back again with the JakartaEE community. Thanks for inviting me back for another tech talk. And thank you to everyone. Hi, Angrub. I can see you on the chat there. Thank you so much for joining today live, and for everyone watching the recording. Really appreciate your time as well. So as Serena said, today I'm going to be covering cloud native DevTools, taking a look at how we can really bring the cloud back down to earth, those cloud native technologies that can really help us to be more productive and more effective at building cloud native Java applications. So without further ado, I'll get started because I've got a lot of tools to go through today. So the first question I really want to tackle is, why are we interested in this? Why are we bothering to build cloud native applications and trying to be more productive in this space? I think if you've seen my presentations before, you might have seen these analogies. I just love them, especially any Disney references. So if you've seen Toy Story, hopefully you'll get the reference. But essentially, it's this feeling we get as developers, this excitement that the cloud brings of, ooh, the cloud. We get benefits from the cloud that are harder to be able to get if we're running things, applications on premise, for example. We get things like flexibility, portability, resiliency. So there's a lot of benefits that we get, and things like being able to take advantage of the latest innovations and trends within the industry much, much easier because these services are much more readily available in cloud platforms. So all of these benefits get us as developers excited about building cloud native applications. But it doesn't always feel this way. A lot of the time when we're building cloud native applications, if you're a little bit dramatic like me, it feels a bit more like this. It can be frustrating, there can be bugs everywhere, it can be a classic, well, it works on my machine. Stuff works in one environment, not in the other. It can be really frustrating. So how can we utilize developer tools? How can we make this easier for ourselves when we're trying to develop effective cloud native applications? So in order to do that, we're going to take a look at, okay, what as developers do we need? What are our requirements? What are we doing on a day-to-day tasks in terms of, what do we need at each of those stages of those tasks to be able to help us be more effective and more productive? So as developers, our role has started to expand more and more. We're seeing more and more terms like not just DevOps, but DevSecOps, BizDevSecOps. It's growing and growing and growing. And as a result of that, it kind of reflects the fact that we're getting more and more tasks and responsibility placed on our shoulders that we have to be aware of and account for in our daily tasks. But essentially, when we boil it down, at the moment, what we're kind of looking at as developers is the following tasks that we often have to do on a daily basis when it comes to developing cloud native Java applications. Sometimes we might be required to create a new project. If not, we're probably going to be adding to that new project or adding to an existing project, editing code. At some point, we're going to have to build the application. Normally, that involves packaging and running it. Hopefully, as all good developers, we are testing effectively too. So testing our code, not just testing it with existing tests, but also writing new tests for any new functionality we might be adding into these applications. Then we've also got things like effective deployment, especially as we're moving to those cloud native environments, being able to, as I mentioned, those roles are expanding. It's not just development anymore. We're also in charge of some DevOps. So effectively deploying, having tools that can help us with effective deployment too. And usually many of these tasks will be happening within a choice of editor or IDE. As developers, I would say we're a pretty opinionated bunch, and that goes to IDEs as well. So in this presentation, in my demos, I'm going to try and show a variety of different IDEs just to show that, this isn't limited to one specific development environment. This is across many different IDEs and can be sort of deployed and used in many of those different environments, depending on whichever one is your favorite role that you use. And often with all of this, it would be great if we could have some coding assistance, if possible. So when we kind of distill all of those sort of feelings and wants and needs and tasks that we have as developers into sort of a diagram of some kind to kind of follow this and to be able to go through each stage categorically, we get a diagram that looks a bit like this. So we have some form of creation, whether that be creating a new project or whether that just be adding to an existing project. We then go into, okay, once we've added or edited some code in that project, that application, we're going to want to build it. We might then, once we see it built, want to edit it more. So more editing. We're going to want to test whatever we add to that application. And at some point, once we go through this cycle, maybe a couple of times, depending on what we're developing, we might then want to deploy it to see what it's like in staging or in production or whatever it might be in development. And all of this, as I mentioned, normally happening within some kind of IDE or editor environment. So we're going to take a look at each of these phases within this diagram and take a look at, okay, this is kind of a distilled image of what we as developers have to do. So how do we apply tools to each stage of this diagram to help us be more productive for this task? And so this is where the how comes in. So for this, often we have kind of two routes we could go down. So we could go down the route of, this kind of like, beam me up, Scotty, take me up to the cloud. I'm going to develop within the cloud itself. The issue with this is that it can be pretty challenging at times. There are restrictions to this. One restriction would be we always have to be able to be connected to the internet. We have to have a solid, stable connection. We might be limited with the tools that we can make use of to whatever cloud we might be sort of invested in. So there are restrictions to this, and sometimes it can be tricky because we might not be able to use the tools that we want. We might not always have internet access. We might not always have a stable connection. And all of this can cause sort of tension and potential conflict and issues and challenges. So instead, what I'm going to focus on today is the other technique of, instead of going up to the cloud and developing in the cloud itself, bringing those cloud native technologies back down to our local machines so that we can still develop locally without having to be in that cloud environment, but making use of those cloud innovations to be able to help us be more productive and effective. And for this, we're going to be taking a look at mostly open source Java technologies and tools today that you can take a look at. We're going to be focusing, in terms of the runtime I'm going to be using for the application, on OpenLiberty. So if you've not come across OpenLiberty before, you can check out our website. It is an open source project designed to be able to be a lightweight open framework for building very fast and effective Java applications. You can go to openliberty.io. We've got tons of documentation, guides, support. We've even got a blog on there, and you can check it out. It's similar to other products. So, for example, you might have heard of things like Quarkus, JBoss, Wildfly, all of these, Payara, lots of these different runtimes available to help you build Java applications. The nice thing about Liberty is, as I said, it's really lightweight. It is open source, so you can check it out, and it interacts with a lot of other open source frameworks and technologies, one of which is MicroProfile. So MicroProfile offers a bunch of different APIs that you can make use of to be able to be more effective in building upon things like Java or JakartaEE, adding on top of that things like OpenTelemetry, health checks, reactive, GraphQL, OpenAPI, even security with things like JWT, all of this great stuff. This is a slightly older diagram. There has been some recent innovations in MicroProfile that has changed this a little bit. So if you look at MicroProfile 7, which is the latest major release of this open source project, as you can see, there's a much tighter connection between JakartaEE and MicroProfile. Actually, a lot of the same individuals and companies contribute to both open source projects, and now there is a sort of explicit dependency on the core profile of JakartaEE within MicroProfile 7. So given this is the JakartaEE community here, if you're not already checking out MicroProfile, I would recommend you go and check it out. It builds fantastically on top of JakartaEE and offers a lot of really helpful APIs and behaviors that we want to be utilizing in cloud native Java applications. And there's a fantastic overlap between the two and sort of tight community connection there. So we've got MicroProfile, which is another open source technology we're going to be making use of in the application demos I showed today. We've also obviously got JakartaEE. As I said, there's that really close connection between the two communities. These are both open source projects for building cloud native Java. JakartaEE, hopefully, as we're all within the community here, we're already familiar with it. But if you're not, this is essentially the open source future of cloud native enterprise Java. It offers it offers the APIs that were sort of previously within Java EE, that this is the open source sort of future version of that. And it's really being developed by the community, giving developers sort of a really comprehensive set of vendor neutral specifications that can be used for developing those modern cloud native Java apps, really from the ground up. So you can use Jakarta EE with MicroProfile, with runtimes like OpenLiberty or whatever it might be, to be able to have that effective stack for building your Java applications. And we're going to be using all of them in the demos I showed today. I just wanted to get everyone on the same page so we're aware of sort of the technologies I'm introducing and using in these live demos. So without further ado, now that we know which technologies we're making use of in these demos, we're going to take a look at each of these key phases and see what tools can help us when. So the first stage that I mentioned is that creation phase. So it might be that you're required to make a new project or a new application for something within your business. And for this, you can utilize starter projects. This is particularly useful, especially if you have new starters, for example. They're coming in having not used the technologies that you've been perhaps using for years. And this can be a really fantastic place to start and get up and running with a basic application in as little as 10 minutes, really. There's a starter project for MicroProfile. There's also a starter project for Jakarta EE, and often for each of the runtimes that I mentioned as well. So I'll start with MicroProfile. The nice thing about the MicroProfile starter is it's available through obviously a web browser if you want to, hence the screenshot here. But the nice thing is it's also available as an IDE extension or plugin for things like VS Code and IntelliJ. So if you're using one of those IDE environments, then you can download or install these extensions and plugins and have it natively within that IDE environment, meaning you don't have to do as much context switching or switching between different applications on your local machine. The other ones, as I mentioned, you can also get a starter project for Jakarta EE. So that's start.jakarta.ee. I've got a screenshot there to show you. And then as I mentioned as well, you've also got those runtime specific starter projects too. So I've got an example here of the OpenLiberty one, which is start.openliberty.io. You can also reach it directly from the website itself. So with these starter projects, the nice thing about them is essentially just a list of different drop-down options for the various different components that you need to choose when sort of starting off your application. So for example, what do you want the artifact name to be? What do you want the build tool to be? So in this case, in the OpenLiberty starter project, we've got the choice between Maven or Gradle. What Java SE or Jakarta EE version do you want to use? MicroProfile version do you want to use? So it allows you to be able to really set up the key fundamentals. And then once you've selected all of these from the drop-down options, all you have to do is click the generate project to actually be able to get a skeleton application already ready for you. So here is an example of this. This is in Visual Studio Code, and I'm just showing sort of some of the different IDE extensions that you can make use of. There are a ton of different ones out there for things like MicroProfile, Jakarta EE, and for OpenLiberty. So in this case, I'm going to show you through the Liberty tools how you can make use of that starter sort of experience natively within the IDE. So this is a plugin you can use if you're making use of Liberty. So here we're selecting which MicroProfile that we want to create. You can see we're selecting which MicroProfile version here. We're selecting OpenLiberty, we're selecting a Java version, which build tool do we want to use. So it's the same drop-down options I showed in that screenshot before, but in this case, natively within the IDE. Here you can see I'm selecting some of the APIs that I want to make use of from MicroProfile. And essentially what it's going to do, I'm selecting where I want this to be created. And as you can see, it's already being generated. And there it is. In a matter of minutes, we've already got that skeleton application created just from using those essentially those drop-down options. And as you can see, we're running on Liberty. You can see we're utilizing the MicroProfile version that we wanted. And the nice thing about the Liberty Tools plugin is that we have this dashboard so that we can see any applications that are in our IDE. So you can see in a matter of minutes, using these tools, using these plugins, whether it be the MicroProfile starter, the Jakarta EE starter, or a runtime specific starter, really, really quickly, we can have a basic application that we can then work from and develop further and edit further without having to set this all up from scratch. So really saving time there in that initial creation stage. Next up on that diagram that we showed is the build phase. So what can we use to make this more effective and efficient for building cloud native Java applications? One thing is using dev mode. So it can be really tedious to have to rebuild and repackage and redeploy our applications every single time we want to see any changes that we've made to our code or our configuration. But to make this easier, many modern runtimes offer the ability to be able to have this kind of dev mode or dev mode equivalent. So in Liberty, it's called dev mode. In other runtimes like Quarkus, for example, it's called hot reload. So many runtimes offer this. And essentially what it offers is the ability to be able to start a server and enable that server to watch for any changes that might occur within your application, whether that be in a class or code or in configuration. And when it sees changes happening, it's able to dynamically rebuild and repackage when needed and redeploy. So it really takes the onus off developers to have to do that and allows us to have a much more agile process. We can see the changes we're making immediately, and it gives us that ability to be able to have live test changes. So it's really, really sort of built for that cloud native agile development that we really want to be getting to for cloud native Java apps. The nice thing with dev mode in this case for Liberty is it's offered as either a Maven or a Gradle plugin, so you can use either of those build tools. The snippet here, for example, shows sort of the Maven plugin, for example, that you'd need here. And the runtime under the commands underneath, so Maven Liberty Dev or Maven Liberty Dev C are the two commands you'd need to be able to actually use Liberty in dev mode. The difference between these two here is that dev is just running sort of locally on your own machine. Dev C is actually running within a container. So it's nice to be able to also have that container integration too, especially given we're moving to the cloud, and often we'll be utilizing technologies like Docker or other container technologies to actually run our applications. So this is a fantastic way of really saving time having to tear down our applications and restart them up again when we want to see those changes. Much more agile and much more sort of aligned with cloud native technologies. Now, if your runtime doesn't offer this natively within it, there is the option to use open source libraries and tools like this one. So this is WAD, which is Watch and Deploy. This was created by Adam Bean in the community, and essentially it does very similar things. So it's able to watch out for any changes that we might make in a project and redeploy our application. So again, it offers very similar capabilities if your runtime doesn't offer this natively. If you're using something like Quarkus or Liberty, it is native, but just in case, I wanted to be able to give the option that, you're not restricted depending on which runtime you're using. So this can really help at this build stage, offering more dynamic, agile sort of building of our application, so we can more sort of easier and much quicker see the changes that we're making to our code to be able to ensure that we're sort of seeing the behavior that we want to in our application. Now we're on to the third stage in that diagram. So we've gone through creation, we've gone through build, and now we're in that edit phase. So how can we use open source tooling to be able to make us more effective when it comes to editing the applications themselves and editing any code within them? So I've got a couple of tools for this one. The first one is making sure that we're utilizing the plugins that are available in the IDEs that we make use of to be able to have sort of, it might be, for example, support for editing, it might be support for developing. So the example that I have, for example, is Open Liberty. You can see the Open Liberty tools shown here for the Visual Studio Marketplace. And the nice thing about this is it allows us to be sort of more effective in not just developing, but also assembling and deploying our apps in Open Liberty. So it supports things like editing the Liberty server.xml configuration files, developing MicroProfile applications. And as I showed in that earlier example of that code, it also has a Liberty dashboard to be able to help us organize our projects with just a few clicks. In that dashboard, we can do things like start, stop our app, run tests, and view test reports. As well as that, we have things like Liberty Dev Mode, as I mentioned earlier, and all of this you can access using these plugins directly from the IDE. So it allows us to be much more effective when we're editing, instead of having to context switch all the time and having, the tab hell where we're having to bookmark all the tabs that we need in a browser. We can have it all within our IDE. We don't have to be switching to the command line, for example, or to a browser. We can focus just on that singular environment. So making sure we know what's out there, we know what we can make use of. If you're using MicroProfile, if you're using JakartaEE, if you're using a runtime like Quarkus or Open Liberty, making sure we have the IDE plugins that are going to help us be really effective in that environment. The next tool I wanted to cover for this section is also things like coding assistance. So what coding assistance can we get in an editor or IDE for these open source tools? So you're probably aware of the coding assistant editors can give us for working with Java projects, but what about specifically working with the open source Java specs like MicroProfile or JakartaEE? This is where things like the language server projects come in. So these are essentially offer the ability to be able to have sort of in-editor language features for MicroProfile APIs be supportive. So things like offering code completion, the snippets for popular APIs, diagnostics, or even quick fixes when you use an API incorrectly from these specifications. It also offers the ability to be able to feedback to fix or enhance code before you run your application. So we have them for both Jakarta EE and MicroProfile. The one I'm showing here is the language server for MicroProfile. Its shortened name, we just love acronyms. Its shortened name is LSP for MicroProfile, or MP. And this lives under the Eclipse Foundation and can be utilized. You can see, you can contribute to it here. To use it, you just need to install the plugin extensions for your IDE of choice. So there's a VS Code extension from Red Hat, for example, which is tools for MicroProfile. And we also make use of it within the Liberty Tools plugin that I showed earlier. As well as MicroProfile, there's also a sort of associated project, which is for Jakarta EE. This is LSP for Jakarta. Bear in mind, both of these are incubator projects, again, both under the Eclipse Foundation. This one for Jakarta EE is a very similar project to the MicroProfile one. It also offers things like code completion or snippets, diagnostics, quick fixes, and allows you, again, to have that feedback to be able to fix or enhance your code before you actually have to run your application. So as I said, they're both incubator projects, so they are still being actively developed and improved. So if you wanted to go and take a look and let us know, is there something that we're missing, a feature that you'd like, or an issue you're running into, please let us know, because we're always looking for contributions in this space. But these tools can really enable us to be effective in this editing phase, ensuring that we're getting those APIs correctly, we're utilizing them correctly within our application, and are being as effective as possible when using them. So here I have another demo here. This is to show the language support for MicroProfile in this case. So in this particular example, I'm running this in dev mode. You can see that down the bottom that I'm running in dev mode in my terminal there that's embedded here. And what we're doing here is we're wanting to create a cafe controller class for my application. We're going to be using the @REST client annotation from the MicroProfile REST client API. And right away, we're going to see, I've got a warning. We use the quick fix to be able to actually sort of fix that. So you can see we've got @REST client. We're starting to add some code in here, but you can see it's really not happy. You can see it's identified what the problem is. So we've got some diagnostics there. And we can use the quick fix to be able to say, I didn't have my CDI bean. I need to also use the @inject annotation for this because we're using CDI. So you can see in just a few clicks, without having to look up documentation, what's going wrong, why is my code incorrect, we've been able to diagnose that we're not using it correctly, and also give that quick fix of, actually, you forgot this annotation, that's what you need to add in to be able to effectively use this. So these language servers can be really helpful, especially for newer developers who aren't as familiar with these open source specifications, to get them sort of productive and effective with code that is sort of best practice and also going to work well for your applications really, really quickly without having to, again, switch around to documentation and things like that. So a really powerful tool here that we should be making use of if we're making use of MicroProfile or Jakarta EE. Another tool we can make use of is code generators for this edit phase. So there's lots of tools here we can make use of. So this is really, if we want to do things like generate snippets of code or generate boilerplate code, we can utilize tools like code generators. So tools like OpenAPI tools, for example, it allows us to be able to generate MicroProfile REST client from OpenAPI documentation. We can use that either through the CLI, or there is also a VS Code extension for this as well. For example, there's a screenshot on the right-hand side showing how you would make use of this within VS Code, for example, and we're going to show a live demo in a minute as well. And this, as I said, enables you to be able to generate a MicroProfile REST client directly into your project without actually having to create it sort of from scratch. You can just use the OpenAPI documentation that you've got in your project. Additionally, you can also generate things like JAX REST stubs too, also using those OpenAPI tools. So if I go into it, here we're doing another demo here. This is for the MicroProfile REST client generator, as I mentioned. The aim here is we're going to be wanting to create a REST client to connect to our REST service, again, using that generator. So we're going to utilize, it's going to prompt us for an OpenAPI document. That was the OpenAPI document, and we're going to pass that in. We can click generate. We're going to verify the package name that we want to use. And essentially what this is going to do is it's going to create a whole REST client interface based off of that OpenAPI document that we had. we'll get the API folder, and in there we've got the models folder. If we go into that, the model folder was essentially generated to work with our drink object based off the drink schema that was in the Open APIs document that I passed it. In this Open APIs folder, we will get some exception classes. Let me just double check this. Yeah, we're just double checking here that we've got the correct information that was generated, as I said, from that Open API document. So in here, as I said, we have some exception classes here, and the default API class. This is the bulk of what we really need to get this working. This is sort of the whole client REST interface. We can see it has all the endpoints with the right post and get annotations from our REST service. And so all we need to do to be able to actually make use of this API class is to make use of this default API class in order to control our REST service, essentially. So to do that, we're going to add a base URI, which you can see here. And so we're going to point this base URI to the REST service of our application. So copy that over from the Open API documentation, paste it in, remember to save. And now we'll be able to make use of this for enabling us to control our REST service. So you can see, without having to start this from scratch, I've been able to generate a lot of code here from just the Open API documentation I already had in my application. So again, saving us a lot of time and effort and energy when it comes to this edit stage of our development tasks and developing cloud native applications. So I'm going to pause there. So far, what we've covered is we've covered creation, we've covered build, and we've covered a lot of different tools in that edit stage. The next stage, as I mentioned, as all good developers, which I think we all are, is ensuring we effectively test our application to make sure that the cloud native applications that we are developing are behaving as we intended them to, ensuring that we haven't got any issues or errors or bottlenecks potentially in our application. So to do this effectively, we can obviously make use of the usual suspects, things like JUnit, or it might be Alquillian you're using, but we can also make use of container native technologies like test containers to be able to mimic our production-like environment on our local machines. So giving us much more confidence that the code that we're developing works as expected, not just on my machine here, but also in an environment that is much more similar and has more parity. You know, going back to the 12 factors, the 15-factor app methodology, having that dev prod parity, that environmental parity, is so important to ensuring we have that high level of confidence that our applications are going to work effectively when we switch from deploying to development or staging to deploying to production and having our customers actually use the code. So test containers is a fantastic way of being able to do that. I've written an article on that, and you can access that through the link at the bottom. But essentially, what it allows us to do, as I said, is really utilize container technology to be able to mimic that production environment in a much tighter way. Test containers, as I mentioned, this presentation is full of open source projects and technologies you can use. So you should be able to have a go at using this as well as the other technologies I've talked about today. It's an open source framework that provides throwaway, lightweight instances of any sort of backing services. So things like databases, message brokers, it might be a web browser, really anything that can run in a Docker container. Being able to have those sort of throwaway instances so we can use them for tests locally on our own machine and have them as close to production as possible. It can be actually really useful for not just sort of data access layer integration tests, but also things like UI and acceptance tests, as well as application integration tests as well. The way that it might work is a little bit like this. The nice thing is these tests are really easy to set up and run, and they run in the same way that you would run them in production. So you can see I've got my two boxes here as a comparison for what would have happened and what would happen with sort of as if it was running in production. So here on the top, you have your integration tests, which are written for and in test containers. We then have our application running in a container and any backing services. So in this case, a MongoDB database, again, running in a separate container there and interacting together. So we're able to use our integration test to test the integration between these and ensure it's working as expected. If we were to look at what would happen in a production environment, we see that actually the integration tests are essentially just taking the place of what our end users will be doing anyway when it's running in production. So you can see much greater parity there, much greater similarity between those, allowing us to have much greater confidence in our applications. So these tests, the nice thing is that because it's open source, they are able to be used with many different runtimes that have compatible implementations. So as I mentioned, you could use things like Liberty, but you could also use things like Wildfly, Pyara, Quarkus. You get a lot of flexibility in that because you're using these open source frameworks and you don't have that vendor lock-in, which is great. If you wanted to have a go with this yourself, we have an open source guide on this that you can check out. Now I'm going to stop sharing because I'm going to switch to that. I've already got it up and open so that I can show you, hopefully live, what this is like. Allow and then share. Fantastic. Okay. So the way that I got here was essentially I went to the Open Liberty website. As I mentioned, this is all open source, community driven. And in here, I've gone to the guide section of this website. These guides are freely available. We work quite hard on them, so we'd love for you to use them and let us know if you like them. In here, we've got I think it's more than 60 guides now on a lot of different cloud native technologies. So if you're new to Jakarta EE or you're new to MicroProfile or you're just new to developing cloud native Java apps, this is a fantastic place to start to really get up to speed on the different APIs in those open source community specifications and different cloud native technologies you can use to build effective cloud native Java apps. So everything from sort of getting started with Open Liberty through to each of the sort of different categories you see here on the left-hand side, whether it be achieving effective observability for your cloud native apps or configuration or security or persistence, whatever it is, we've got a lot of different guides here that can help you learn about those in as little as 15 minutes. Some of the guides go up to 30 minutes, but anywhere in between those. So nice and quick and easy and very consumable for you to use. So in this case, we've gone to the test category here. And you can see we have lots of different test guides within this. In this case, we're looking at the Building True to Production Integration Tests with Test Containers guide. Now, as you can see, we have these tags, I would call them, which just shows which of these guides can be used with our cloud native environment versus which can be used either they're deprecated or they can't be used in the in-cloud, they have to be used locally, or maybe they're new. So you can see this one is both new and can be run in our cloud native environment. When I click on this, I'll be taken to a page that looks more like this. All our guides are set out in the same way, so it's quite easy to go from one to the other without having to learn it all from scratch. Normally what we'll have in the guides is the first section is sort of explaining what you're going to be learning in this, hopefully giving you an idea of whether this is going to be useful to you or not, and then any prerequisites you might need. Note here, if you are going to be running these locally, you can also run all of these guides locally if you don't want to run in cloud. Note that you will need any prerequisites that are mentioned in the top right-hand corner here and any additional prerequisites that are mentioned within the guide itself. But what we're going to do today is use the running cloud option. When I click that, I'm going to be asked to log in, but you can log in with lots of different social logins, whether it be just with an email and you create an account, or with things like LinkedIn, or in this case, I'm logged in with GitHub. Hopefully, everyone is able to access at least one type of social login that we provided. But please let us know if you aren't, and we'll look at sort of working on a solution for that. Essentially, when we're here and logged in, we'll be asked, do we want to access our cloud-hosted guide? We'll click that button, and it will take us to our cloud-native environment. So this is loosely based on sort of a Thea-based IDE, and essentially what it has is the instructions on the left-hand side here, the IDE on the right, and the terminal on the bottom. If you don't see a terminal on the bottom, don't panic. All you need to do is click Terminal, New Terminal, and one will appear for you. And you can actually move that around depending on where you prefer it to be in this environment. But in this case, I'm just going to close these extra tabs. We have we've got terminals already open, and I've already gone through some of the guide just in the interest of time, trying to get through everything just to show you today. If I go to the beginning just to show you where we're at. So in this case, again, it's giving you an idea of what this guide is all about, what's the purpose of this. This is what you're going to be learning, including a bit of background information in case you're not familiar with test containers. In this case, we're using the application that we use in most of our guides, which is a fairly simple application just to help you get up to speed quickly and not have to context change between different guides. It's got a system microservice and an inventory microservice. The system microservice is scraping your system data every 15 seconds, and the inventory microservice is just storing an inventory of all that information. In this case, we're utilizing a backing service so that we can show you how to enable integration tests for something like this. And so we're storing the information from the inventory in that Postgres database, just so we can sort of demo test containers effectively here. So this is all open source, as I mentioned, so you can check it out on GitHub if you'd like to. In this case, I've already gone through these instructions. I should mention that in this cloud native environment, the nice thing about it is A, you don't have to have any prerequisites. All you need is a browser, which is great, especially for machines that might be locked down. And the second thing is that we've tried to make it as seamless as possible to use. So we've got copy buttons that automate sort of copy paste, but we've also got execute buttons that allow you to, all you have to do is click that one button and it will automatically go into the terminal and execute for you. So here I've already done a git clone, I've already CD'd, I've already done this step, which is just because of the environment we're using, we had to change the home project by running this sort of command. Now in some of our guides, what you can do is just go straight to the finished product. So if I open up my Explorer view here and access my project, so what you can see here is we use the same structure in all of our guides. So we have the start project and the finish project. In the start project, that's where you're going to start and go through the steps of this guide. In the finish project, that's essentially what you should end up with at the end of following all the steps. So if you just don't want to go through the guide and you just want to see what happens at the end, you can just go straight to finish, or you can use it as a check in case you introduce any accidental bugs or anything goes wrong when you're actually following the steps in this guide. So in this case, I'm just skipping past this because what we want to do is actually learn how we use test containers. So in this, I've already set up Docker to run my Postgres SQL database, again, in the interest of time. So I've already gone through all these Docker build and run commands and confirmed that I'm running on the same port here, for example, or have the same IP address. I've also already got Liberty running in my dev mode. Let me just double check this is appearing correctly. I might have closed that. Let me just double check this is still running. Yeah, so that's still on the same port. And let's just go here and double check. We still already done that. So let's just make sure it's running in dev C again. So in this case, I'm using Maven. All of our guides use Maven, but as I said, you can use Maven or Gradle depending on your preference. In this case, I'm using the Liberty dev C command because I want to be running Liberty. Actually, I think I needed to, let's have a check. Yeah, because I want to be running Liberty in the container because essentially, as I mentioned in that diagram, we want Liberty running in a container and our backing service running in a container so that we can effectively test the integration between those containers as if it was running in production. So we'll just give that a minute to start up. Just double check that's working. And then we know it will be running when we see this message, which is Liberty is running in dev mode and a line of stars, which essentially lets us know that our Liberty server is ready to get going with. So let's take a look if this is, we're getting there. Just needs a few more, there we go, application inventory started, great. The default server is ready to run a smarter planet. Okay, fantastic. So that should be ready to go. So now if we open up the Open API UI, so which is basically just Swagger, what we can see here is actually, if we go to the Open API UI endpoint, it basically provides a visual way for us to be able to interact with the APIs and test out the functionalities. So you can see here, we can see the different APIs. We can, see the details in them, for example, or any schemas. We can interact them and try them out, for example. So it's a really useful way to be able to test it's working in our application. So in terms of building, sort of utilizing test containers, we need to be able to build a REST test client first. This is going to be responsible for sending HTTP requests to an application and handling the responses in it. So for this, we're going to be using this touch command. But first, because my Liberty is running in dev mode, this terminal is taken up with that. So I need to go to a new terminal to be able to actually do this. So I'm going to use this touch command to create a system resource client class. And I'm going to use this button here as a shortcut to be able to access that in my IDE. I'm going to copy and paste the code that's provided here. Cool. Let's just check that that's all good. Yeah. So I'm going to copy and paste all of this code into my class. And remember to save because this environment does not automatically save. Essentially, what you can see here is this interface is declaring things like list contents, get system, add system, all of these methods to be able to allow us to access the corresponding endpoints in our inventory microservice. The next thing we're going to do is create the system data model for testing. So again, I'm going to use this touch command just to make that really easy using that execute button. Open it up. It's empty because I've just created it. I'm going to copy and paste everything that's provided here. into this and remember to save. There we go. That dot will appear if it is unsaved, just an FYI in this environment. So essentially, this class is containing things like the ID, the host name, the operating system name, and the various get and set methods within the class that enable us to be able to view and edit the properties of each system in the inventory. So now that we've got those set up, we can actually build a test container for OpenLiberty. So for this, we're going to be we're basically going to be creating a custom class that is going to extend the test container's generic container to define specific configurations that suit our application requirement. So to do this, we're going to create a Liberty container class first. So we're going to execute that and open it up. Again, it should be empty because we've only just created it. I'm only going to copy and paste in the code provided here. So in this, what you'll see is we're actually extending the generic container from test containers, as I mentioned, to be able to create this custom container configuration that's specific to the OpenLiberty application. We've got things like the add exposed ports method that allows us to expose specific ports from the container's perspective, allowing our test clients to communicate with any services running inside those containers. By default, the wait log message method directs the Liberty container to wait for the specific log message that basically indicates the Liberty instance has started successfully before trying to test it. If you want more information about the APIs that we're making use of here, you can visit the test containers documentation and get more info on that. So next, we want to write tests that use this to be able to actually see, is it working? So for this, we're going to create the system resource IT class, open it up, and in here, again, copy and paste the code that we have in here, and remember to save. So if I scroll all the way down past this, so what you can see is we're constructing the Postgres image using things like that Dockerfile class, which allows the test containers to be able to build Docker images from a Dockerfile during the test runtime. For these instances, the provided Docker files at the specified ports are basically used to generate the respective Postgres sample and the snapshot images for the inventory. As I mentioned, we're extending this generic container class, so we're going to be using it to create the Postgres container testing container to start up that Postgres sample Docker image. Again, talking about things like starting up these Postgres images as those lightweight throwable instances just for testing here. We're also going to use it to test the Liberty container custom class, again, using the inventory snapshot Docker image. So this is basically allowing us to be able to use unit tests within this class to be able to test individual parts in those integration layers in our application. In the interest of time, I'm going to leave, if you guys want to delve into this in more detail, I'm going to leave you with the guide if you want to go through that. I'm just going to go through the other steps just so I can demo this for you. So I'm going to add the log4j properties file. This allows us to be able to have reliable logs for things like debugging when it comes to this. So I'm going to open that up, copy and paste in the code that I need, and remember to save. Just make sure that's saved. There we go. And then I'm going to configure my Maven project to be able to make use of all of this. So if I go right down to the, what was it, at the top? There we go. So if I copy and delete all of that and paste and save. And as you can see in the background, if I go back to this other tab, because I've been running in dev mode, all of these changes are automatically being picked up for me in an agile manner. So it makes it really easy to do all of this. So now if I go back to this terminal and I go back to my Liberty server, in order to start the tests, you just have to click enter or the return key. So if I do that now, it should hopefully pick up what I've been doing and try the tests and see if they work, essentially. So hopefully, yeah, what we can see here is we've got 3 tests running and we were able to pass all 3 of those tests. So in just about 5 minutes, I've been able to get this application up, running with dev mode in a container, get my Postgres running in one of those throwable instances. Using test containers, I've been able to effectively test the integration between my Liberty microservices and the Postgres database as if it was running in production. So much more efficient way to test our applications. If you want to try that out for yourself, as I mentioned, head to our OpenLiberty guides and you can follow exactly what I've been doing in this demo today. So I'm going to stop sharing. That was a whistle-stop tour of that, but I'm going to get back to the presentation just so I can finish this with some additional tools for those extra sort of steps that we were talking about in that diagram. Okay, so moving on from test to deploy. So what can we have, what tools can we use to effectively deploy for cloud native applications? in a much more sort of productive manner. So one of the things, or one of the open source tools that you can make use of is Buildpacks.io. So this was a project that was initiated by Pivotal and Heroku, so the creators of the 12 Factors app methodology, back in 2018, and it joined the CNCF in October 2018. The idea of this is to really unify the Buildpack ecosystem to be able to have sort of a standard for platform to Buildpack contracts that's really well defined, and allows us to be able to embrace things like modern container standards, things like the OCI image format, and take advantage of the latest capabilities of these standards. Things like cross-repository blob mounting and image layer rebasing on Docker API v2 registries. So having a standard that's really at the cutting edge of standards and sort of protocols and process and have those capabilities and innovations. What it allows us to do is it allows us to be able to transform our application source code into container images that can run on any cloud without having to have the need to manage Docker files within our application. So all you need is to have your source code and the Buildpacks specification, and the Buildpacks is essentially able to take those two components using the Pack CLI, turn it into an image that's ready for deployment to the cloud. You might be thinking, okay, but how does this compare to technologies I might already be using, like Docker files, for example, or you might be using source to image or JIB, whatever it is. You can take a look at the buildpacks.io/features page, and this has a detailed breakdown of all of the sort of capabilities that are offered by each of these and how Buildpacks compares. The nice thing about Buildpacks over sort of alternative technologies is the fact that you don't need to bother updating and creating a Docker file. You can use things like advanced caching. You can also utilize things like having a software bill of materials created. Security is becoming ever more important, and knowing what is in our application is crucial for that. So being able to have an up-to-date, built-in software bill of materials support in these tools helps to provide insight into the contents of our application image and if we're at risk from a potential security or vulnerability. It also allows us to, using things like Buildpacks, allows us to be able to have things like minimal application images because the images only contain what is really necessary. And it allows us to have that all-important reproducibility, not just it works on my machine. Being able to reproduce the same application image every time we build it. It also allows things like auto detection, so images are automatically built directly from our application source code, and things like rebasing, as I mentioned. So some fantastic benefits of using tools like this. So building on top of the concept of Buildpacks, Paquito created the Paquito Buildpacks. This is an implementation of that CNCF specification that's available for a wide variety of languages. So the nice thing is this isn't Java specific. You can use it with Java. You can also use it with .NET, Go, Node.js, Ruby, whatever it might be. There's lots of different languages supported by this. And this is essentially, this was created using really the knowledge of many years of experience where the Cloud Foundry community sort of engineering team created this project based on sort of former Cloud Foundry Buildpacks. So just build on that specification, but it also adds additional sort of capabilities and language-specific implementations. So in Liberty, we have actually got a Paquito Liberty Buildpack that provides the OpenLiberty runtime to a workflow that is able to produce an OCI image that can run just about anywhere. And the nice thing is it's really easy to use. So we've got some documentation on this as well as some blogs. But essentially for this, you just need to be able to specify things like what builder you want to use. For example, a builder is essentially an image that contains all the components necessary to execute a build. So it's normally things like a set of build packs, which provides your app's dependencies, a stack, which provides the OS layer for your app, and the CMB lifecycle, which basically puts everything together to produce your final app image. So in this case, this screenshot here, we're just using the base builder in this case. But as you can see, in just a few steps, you can get started using a build pack for your Liberty applications. I do have a quick demo here, but in the interest of time, because I know people might have questions on some of these tools, I am going to move on from this, but I will share my slides. So if you want to check out this demo afterwards, you should be able to in the slides that I share. And then finally, because we've gone through creation, we've gone through build, we've gone through edit, we've gone through test, we've gone through deploy. So we've gone through the majority of that diagram, that circle with the extra arrow, and we've looked at doing it within an IDE through this presentation. One last tool I wanted to raise, which I found pretty interesting to investigate, is Telepresence, which kind of spans a lot of those tasks and sort of goes beyond just that sort of circle I showed of development tasks. So what is Telepresence? Telepresence is really about enabling fast local development for things like Kubernetes and OpenShift microservices. It helps to accelerate that whole inner dev loop and helps to shift testing left and allows us to be able to use our existing workflow in a more cloud native manner. What it enables is it really allows you to be able to swap out a pod that is running in Kubernetes with a service that is running locally. So all requests that would normally go to that pod in Kubernetes are essentially redirected to the local URL and port. At the moment, this is a CNCF sandbox project, and you can check it out with some of the links that I've sort of exposed here. We've got some examples here of using it from people like Nicholas Heidoff and also Sebastian Daschner here. The way that it works is kind of summarized in this image here. So Telepresence consists of two core architecture components. You've got the client side Telepresence binary and the Kubernetes cluster side traffic manager and traffic agent. So you can see point 1 and point 2 there. So where we have point 1 in this diagram, so this is where the Telepresence connect command is able to utilize the traffic manager to establish this two-way tunnel between your local development machine and the cluster. So now you can access any of those remote Kubernetes services as if they were running locally. In step 2 here on the diagram, we're running Telepresence intercept service name. What this does is it triggers the traffic manager to basically install a traffic agent proxy container that runs within the pods associated with those target services. So this allows you to be able to route remote traffic to your local dev machine for you to be able to develop and test. So it's a fantastic way, again, of bringing those cloud native technologies, things like Kubernetes, containers, down into your local machine, allowing you to seamlessly connect between anything that you've got deployed in the cloud and what you're actually developing on your local machine, enabling that whole inner loop. So going sort of taking a step back, we've gone to each individual step in that loop. Now we're taking a step back and looking at, okay, what tool can I use to make this whole thing more productive? And tools like Telepresence can really enable us to bring the cloud back down to earth and be more effective and productive developing cloud native Java apps. So in summary, because I know that was a whistle-stop tour, but I wanted to cover as many tools as I could, because hopefully one, if not many of them, might be applicable to your applications, and you might be able to make use of them to be more effective and productive and happier, hopefully, as developers. So I've got a summary here of where they all fit in. If you're using MicroProfile, if you're using JakartaEE, or if you're using runtimes like OpenLiberty, you can use many of the tools that I've mentioned here to either create starter projects in those create phase, to build and run your application, to have IDE integration and support, code generators, automated testing, and deployment. So if you want to try it for yourself, as I mentioned, we've got the OpenLiberty guides that you can check out. I've got a QR code here to make this a bit easier for you to access. And the nice thing about this is, as I mentioned, you've got the option to use those cloud native labs, so you don't have to have the prerequisites on your local machine, and you can get started with many of these cloud native technologies through that. If you want additional resources leading on from kind of what I've covered here, I've got some links for you to go to if you wanted some extra homework. So things like the Liberty tools that I've shown in the demos here, the OpenLiberty starter, and also the specific extensions for things like Liberty tools and MicroProfile for the IDEs. And I've got links to things like test containers, the Paquito Buildpacks, Telepresence examples, and our OpenLiberty guides, and a deep dive if you did want to go deep into that runtime if you're not familiar with it. Hopefully this has been helpful to you. And I know it's been a whistle-stop tour, but again, as I said, hopefully at least one of these tools is one that you can apply to your own projects and your own applications, and hopefully see a difference in being more productive, happier, and more effective in building cloud-native Java applications. Thank you very much for your time. I will try and get through as many questions as I can here, but if I can't, or you think of a question later, please feel free to reach out to me on social media. Thanks very much.
Thank you so much, Grace, for your wonderful presentation and taking the time and your continuous contribution to the Jakarta EE community. We greatly appreciate it. We do have one question from the audience. It's from Keith, and I will post it up right here.
Great, thank you.
So he says, great talk. Is Open Liberty and Jakarta EE microprofile dominant over other frameworks like Spring at IBM for building cloud native Java apps?
Great question. So I would say in terms of IBM's perspective, we actively contribute to the communities of MicroProfile and Jakarta EE. Open Liberty is a project that has stemmed from IBM originally. So if you're familiar with things like WebSphere, we kind of realized that WebSphere was pretty clunky and hard to use and not really designed for the cloud. So we created a much more lightweight modular runtime called Liberty, and we open sourced that in 2017. So Open Liberty, MicroProfile, and Jakarta EE are where we're putting a lot of investment in. We think there is some great value for our customers and generally for the Java community in these open source projects. And that's where we spend a lot of resource and energy, and a lot of the people at IBM contribute, as I said, to those projects. Spring, on the other hand, is it is a vendor specific implementation. It is not like an open source community driven specification. And so at IBM, we don't actively contribute to Spring itself. So what I would say is that from an IBM perspective, we definitely have a preference for the open source communities of MicroProfile, Jakarta EE, and MicroProfile. That's where we spend a lot of our time, and we love the communities there. I would say the benefits for you guys of using some of those open source specs is that you can have a say. They are open source. Join our communities, contribute, have a say in where the direction that they're going in, what features they offer. That's the fantastic thing about them being open source. And B is you're not locked into one vendor. So the fact that Spring is offered by one vendor and you kind of have to go down a singular path. The nice thing with MicroProfile and Jakarta EE, as I mentioned, there's lots of different runtimes that have compatible implementations. So if you really needed to, you could switch runtime that you want to use. You can switch tools. It offers much more flexibility and portability that we want from our cloud native apps. So I would definitely say if you've not already checked it out, check them out because they are fantastic open source projects that we always want to support.
Amazing. And Keith says, thanks, and good to hear IBM is still backing Jakarta EE.
Yeah.
That's great. Thank you so much, Grace. There's no other questions. Again, anybody in the audience, please share your feedback with us. If you click on the survey, that would be greatly appreciated. And we look forward to having you very soon again, Grace, this year. Your presentations are always full of great information and knowledge. So thank you so much. And you have yourself a wonderful rest of your day.
Thank you so much. Really appreciate joining you guys again.
Of course. Thank you. Bye.